Good afternoon, everyone. Um, Thank you for, again, taking care of all of the signing on the terms of services and the privacy connection. And thanks for joining on the Google Classroom as well. So Sandeep has shared the session recap from our previous session, a session from Monday. Hope everyone had a chance to look through that.
So one of the things I wanted to call out was both the topics for that session and the relevant questions were generated automatically. So that's one of the language models that we are using, just FYI. And we also have a goal where we want to make this a great experience for all of you. So at some point, we'll design a poll where you can provide us some feedback and things that we can continue to improve. So just a heads up that we'll be requesting you to do that shortly. Back to you, Madhu.
Thank you, Sandeep. On that similar note, if during the entire session, any session again, if any of you probably wanted to make a note that, okay, this particular topic seems very interesting, I probably want to revisit it later, or I want to explore a bit more on this topic by using the additional material that we'll be providing. So for those, what you can do is you can just type in the word key in the chat section, and our AI pipeline, it will pick up whenever we run the entire analysis, pick up that information and try to create more like a key moments or a bookmark information for you, so that it would be a lot more easier for you to get to that particular point and probably review the topics that were being discussed. With that, so today's agenda is primarily to cover the rest of the topics from the agenda item that we went through in our session number 2. In session number 2, we covered the various applications of AI, and I was thrilled to see how each one of you have been using primarily the ChatGPT, and we had a very engaging conversation on that. And I hope we are going to have similar engagement on today's session, as well as all of the sessions going forward. And the moment when you have these thoughts that each one of you, when you share it with the rest of the cohort, that's when it would get the ball rolling in terms of sharing your experiences and then the innovative ways how people have been using machine learning. You have been using machine learning, and it would ignite thoughts in others to use it in a similar fashion too. Okay, so in today's session, we'll be focusing on some of the general terminologies, the differences between AI, machine learning, deep learning, supervised and unsupervised learning, classification algorithms, regression algorithms, and how can you identify which type of algorithms to choose when you identify a problem that you want to solve with machine learning. And then the actual machine learning pipeline itself, as in what all steps would you have to go through in building a machine learning model. Okay. With that, let me jump into our AI, machine learning, and deep learning. Okay. So can any one of you take a shot at explaining one or all of these concepts, AI, machine learning, and deep learning, to the rest of the team?
Uh, so AI is basically the word itself says artificial intelligence. It's basically imparting intelligence into machines artificially. So sometimes things are non-deterministic. We can't just program every single scenario. In that cases, we just use some optimization function to solve that. I think NP hard problems into a state where it gives decent results, but although it is not perfect. These kind of systems which we build right now are AI systems. Machine learning and deep learning are machine learning is basically the process of importing that artificial intelligence into machines is called machine learning, as much as I understand. Deep learning is basically uh, uh, all these all these algorithms which use back propagation to train themselves and then uh, reach some optimum point. That's roughly my understanding.
What I understand from deep learning is they use deep neural networks, and that is why it's called deep learning.
Kind of what I understand, and I know we went through this earlier, all these modules, but like machine learning is a subset of AI, and then within machine learning itself, like deep learning is another subset. And then just the deep learning has multiple layers compared to something like machine learning, so it's a lot more complex and even more so widely used than simple machine learning algorithms.
Yep. Any other thoughts? Okay. Thanks, Abhilash, for kicking off on the discussion. So, okay, now that you listen to Apramey, Abhilash, do you agree with any of the thoughts that he shared? Or are you good with his points?
Maybe you're on mute.
Am I audible?
Yes.
Me. Okay. What I was going to add is, you can think of machine learning as glorified statistics. It's just mathematics at work. Most of the algorithms are pure mathematics. They're not actually, how we see it as in just a machine actually learning. The machine doesn't learn anything. It's just our math doing its work.
Mm-hmm. Yes. Okay. Okay. So again, quite different, sort of quite good variation of perspectives that I heard from Abhilash, Shiren, Apramey, and Aditya. So just keep one of the aspect in mind that when you have to explain, let's say, artificial intelligence or machine learning, try to think of, okay, what is the difference between these two? Maybe that might become a lot more easier in your mind to explain it to others, right? So from that perspective, let's say, with respect to your explanation on AI, pretty much I think everyone nailed it. An artificially intelligent system which can take most of the intelligent decisions by itself, right? And on that end, any system that can take those decisions by itself is an AI system. And the major difference between that and machine learning is when that decision, the intelligent decision that the system is taking, if it is being taken explicitly through a logic that a developer has coded in, okay, then it is a segment of artificial intelligence which does not include machine learning, so which means everything else. Now, the moment when you don't need to write an explicit code for the system to take a decision. That type of intelligent system would be a machine learning system. So a very simple and small difference between AI and machine learning. If you are manually writing the code for the decision that needs to be taken, then it's simple AI system. And if the decision is being taken by the system by identifying the patterns in the data that you are providing to it, that's where the learning happens. Okay. So that's why you call it as a machine is trying to learn the patterns or the insights and create a logic by itself based on the mathematics that you're talking about, Aditya, right? So those systems are called as machine learning systems. Now, can anyone take an example of AI system and also an example of machine learning system? Or, sorry, I have to be very specific in my question. Can you take an example of a system where you write the code explicitly and also you don't write the code explicitly?
For example, of where you don't write a code explicitly could be something like a neural network. And there's one thing I wanted to ask. So there are algorithms like random forest, where you don't specify the logic, but after learning, it converts into a series of if-else statements, which are explicit knowledge logic. So which domain does it fall into?
So since you are not writing that if-else conditions, Chiren, so the developer is not writing, right? The data scientist is not doing it. So the mathematics, the algorithm that we are using, it itself is coming up with all of those if-else conditions. So the machine algorithm, the machine learning algorithm is coming up with those. So you would still call that as a machine learning algorithm or machine learning system.
Got it.
Good question, Chiren. Thank you. Any examples where?
So in reinforcement learning, we explicitly code heuristics like reward system or the way it should work. So that's basically something which we tune so that the model can train better. I don't exactly know if that is the correct example, but I think based on the description, that should be artificial intelligence.
So it is definitely an AI system. Now, if you're saying that over there, we are explicitly writing the logic to make a decision, then no, Abhilash, but you did actually add one point, which is you're writing an explicit logic to give a reward to the algorithm that, yes, you're moving in the right direction. No, you're not moving in the right direction. So I'm going to penalize you. Right. Going back to that example of Mario game that we looked into in the previous session, right? If Mario stands just there, he's going to die maybe within a few seconds because of that demon that will be coming in.
Yeah.
You're going to give the reward or the penalty that, okay, just don't stand there. Just probably keep jumping, right? Now, the moment when the Mario doesn't die, you're telling the machine learning system, or you're telling the system that you did a good job. You're telling it, or you're giving it the feedback, but you're not telling the system, this is the decision that you need to make, right? For example, at this particular instant, at this particular second, you need to jump, or you need to move forward, or you duck, or you go backwards. So you're not controlling any of those decisions. Right. So from that perspective, it's not an actual decisioning system that you are explicitly writing. You're just giving the feedback to the system. Right? So from that perspective, it's not the right example for this scenario.
So Madhu,
Maybe
fair then, instead of saying with explicit logic or without explicit logic, we become more explicit and say without explicit logic for making the decision.
Decisions. Yes, you're right, Sandeep. Yeah.
Maybe an example of the explicit logic would be like something like a machine in a warehouse, like where it has to do a like specific task. Like we tell it to move it like a thing like in a factory line in a specific way. Like we explicitly tell the machine what to do.
At the high level, yes, Apramey. Maybe going a bit more into the details might make it a lot more clear if you probably take an example.
I guess an example would be like, let's say in a factory, there's like a factory line, and then like a specific machine, like as each like thing within it, like let's say if it's like a Nutella factory or something, and it needs to like put the jar on top of it to the lid to close it. Like it's like we explicitly program it like every 3 seconds you need to do this specific task of putting it there, and then you get a new one, and then you do that. So like having that specific example where we code the machine to do that repeatedly, I guess.
Okay. I would like maybe the rest of the court members to provide their inputs if that is a relevant example or not.
That depends a lot on our definition of a intelligent program, because essentially what it's doing is pretty simple. So it also like where do we draw the line on how complex the thing is.
Okay. So please go ahead.
If I understood correct, so the artificial intelligence problems would be mainly like simple optimization problems, like maybe a house price approximation or something like that, where would apply simple linear regression to find what we want. And if we consider machine learning, then in machine learning, we would be using some of those prices like optimization problem, but on a larger scale. So for example, the Mario game, we would be optimizing the Mario game by giving it feedback of it is correct or not. And those would be the algorithms which we use in AI, but on a bigger extent, it would be multiple algorithms which join together to make a process more automated in a way.
Mm-hmm. Mm-hmm. Yes. Yes, Keval. With respect to the example on the Mario game that you took, over there, we would be using multiple algorithms and approaches. For the decision-making system itself, you'd use some machine learning algorithm as a solution. And for the reward strategy, as Abhilash shared earlier, you'd be creating a strategy for the reward system using explicit logic. So it's a combination of both of them.
I had a quick question. Are recommendation engines an example of AI or ML? Like, where do they belong?
Okay. So, actually, you know what? I don't know if you saw the... Okay, let me move on to the next segment. I think you are talking about... Okay. So let's talk about, again, both of these specific applications. First, the robot vacuum cleaner. Over there, now you do have few sensors on the robot, and the moment when it sees any obstacle, is it going to still keep? Is it still gonna move forward? No, right? It's gonna change its direction and then move in a different direction. Now, no one is going to explicitly write a code that, okay, the moment when you hit a roadblock, hit something. Sorry, let me take my statement. When you hit something, when the sensor senses something, the solution that you can take is, okay, there is obstacle in front. Now I need to change my direction. Or of my movement. Someone can manually code it as, okay, maybe turn clockwise, move by 45 degrees or 90 degrees, most of the time 90 degrees, and then keep moving forward until you hit another object. And then even at that time, it's going to take similar decision. Now, if it's explicitly written like that, then it is, since it is making a decision by itself, but a developer has coded that. If there is an obstacle, which is determined by the sensor, the IR sensor that is present on the vacuum robot. So that would be your input signal. And the decision that it's taking is, again, through an explicit logic that a developer has coded to turn clockwise and then move forward, turn clockwise by 90 degrees. So that is a simple AI system where you have an explicit logic for the decision-making system. Now, coming back to the recommendation engine that you talked about, Ananya. In Netflix is one of the top most companies or the services that comes to your mind whenever you talk about the recommenders on movies or TV shows in this case. Do you think someone is going to do a hard coding of, let's say if Ananya watched triple RRR movie, maybe suggest her these other movies?
I don't think it's gonna be hard coded for a reason, because it's a variable and nobody can like hard code what next to watch based on someone else's experiences of streaming Netflix.
Yes, I mean theoretically you can. No one is stopping you, right?
Yeah.
No one is stopping you. It's just that, is it scalable? Maybe you can do it for Ananya. Maybe we can do it for Aditya and Bitan, but you cannot do it for each and every learner, right? So that's where the power of machine learning comes in, right? It tries to identify all of the patterns. For example, if we try to understand the viewing behavior of Ananya, Aditya, Bitan, so everyone in our cohort, maybe we might be able to do or take a decent shot at recommending maybe an algorithm for a movie for Sandeep. Again, bottom line is, the moment when you start to capture the behaviors of, in this example, different viewers, identifying the patterns and extracting those patterns and see who else have similar viewing behaviors and accordingly show them these specific recommendations. Over there, all of that is being done through mathematical algorithms, and you'd be deploying them for making real-time decisions for each of the new viewer. Doesn't have to be new viewer, any viewers on Netflix. It's not, bottom line, it's not hard coded.
Yeah.
So those types of solutions of AI systems are called as machine learning solutions. Okay. Did that help in terms of distinguishing between the AI systems where you explicitly write logic for taking the decisions, and where the algorithm sensors are writing the code to come up with the logic?
Yes, it very did for me.
Sorry, what did you say, Anvi?
Sorry?
What did you say?
I said I was unclear about the recommendation system, like where it fits in, but I'm like very clear now.
Okay, great. Thank you. Did someone else have a question?
Oh, yeah. So I wanted to ask, where would something like NaiveBayes, which is essentially a statistical model where you write down all the explicit knowledge and the only thing that varies is the data. So would fall in artificial intelligence, right?
Okay. So thanks for bringing in this point, Chiren. When you said you are explicitly writing did you use the word logic or?
Yeah, you're using a statistical model, so the
Right.
only thing that varies is the data, but everything else is the logic is still the same.
So you are okay. Let's say if you can use NaiveBayes even for recommending something, right? Um, like movies in Netflix. So how would you be coming up with implementing NaiveBayes algorithm for recommending movies? Would you be writing explicit code, explicit logic? I wouldn't say code. Sorry.
I think, yeah, you would be implementing the methods they need to follow, but it would vary according to the data itself.
Yes. Yes. So which means the moment when you said it varies according to the data, it means that it's not the algorithm, which is the mathematical equations, they would remain the same. You're not changing them. And there would be a lot of parameters, right? Like the prior probability that you're using. I know I'm jumping into the actual NaiveBayes algorithm in here. So please stay with me. There would be few hyperparameters that would be present as part of any machine learning algorithm. And there would be core algorithm parameters, like the algorithm variables. If I have to take a different algorithm to explain it a bit better, for example, linear regression, like equation of a straight line, y is equal to mx plus c. Very simple equation, mathematical equation. And it is a very simple linear regression model, single order linear regression model. X to the power of 1, m into x to the power of 1 plus c into x to the power of 0. Here, m and c are your algorithm parameters, right? The slope and the intercept. Now, with respect to linear regression itself, you can add, there would be other parameters called as hyperparameters. In this case, the power of the polynomial function. So we have y is equal to mx to the power of 1. So the maximum power that we have is 1. So the hyperparameter in here is the order of the equation, and it's 1. And you can change that. The moment when you make it 2, it's not going to be a linear equation. It's going to be more like a parabolic equation, quadratic equation, and so on. Cubic equation, and when you have n is equal to 4 and 5, and so on. Now, so those particular, so the equation would be the same, but depending upon the data that you are providing, M and C will change accordingly. And as a developer, you are not hard coding them, right? Depending upon what values the M and C, what values for M and C that eventually the algorithm would come up with, the decision will be taken accordingly, right? So, which means the algorithm, the equation is the one which is figuring out what the values of M and C should be based on the training data that you are providing to it. So the algorithm, the system itself is figuring it out. As a developer, you are not doing any hard coding. The moment when you fix the values of M and C, that's when you are fixing the decision making system. And since the developer is not fixing the values of M and C, it falls into this category. Did that help, Shiren?
Yeah, that makes sense.
Any other questions between artificial intelligence and machine learning? Okay, moving on. Now, let's focus on machine learning and deep learning. Okay, what's the difference between these two, machine learning and deep learning?
By the slide I saw, it means that deep learning is with deep neural networks, and machine learning is, it's a subset of machine learning.
Okay, so so that was a mistake on my part. And Any other details that any of you want to add? Again, either on machine learning or deep learning. Yes, deep learning is a subset of machine learning, but any other points?
It is inspired by deep neural networks, like neural networks which we have in our brain.
Yeah. Yes, Abhilash. Okay. Yes, it is a subset of machine learning, and the way they do work, Abhilash, as you mentioned, it has been inspired by our brain, how the neurons are structured within our brain, and what happens in our brain is there is constant communication transfer or information transfer between different neurons through synapse junctions. um, so think of actually each one of the nodes that you see in a neural network is more like a synapse junction, Abhilash, right? And the rest of the length, maybe if you want to visualize it from the visualization perspective, they can be the neuron body length. Each neuron is quite long, and its head would have a neuron, a synapse junction, where the information transfer happens. And inspired by how brain works, where again there is this constant information transfer happening from one neuron to another neuron, and that's how you can store enormous amount of information, because you have I, I don't know, I'll have to probably look at how many trillions of neurons in your brain. It's even in deep learning, it tries to derive some information at one of the synapse junction and share that information with its subsequent node in subsequent layer, and then it does few calculations on its end, and then it shares that information to the next neuron, and so on. And now, by the moment when you reach the very final layer, you can see that there has been so many connections that have happened. The information has been or is being shared across these multiple neurons. So you would have created so many combinations of information and so many so much of granular and aggregated level of information at different levels, depending upon how you architect this this network. You'd either zoom in or zoom out of the information, mix information, and create insights, get to insights in the very final layer. I'm sorry, just give me 1 second. Sorry. Yes. Okay. Any example on some of the systems that use deep learning?
So would the Netflix recommender system not be considered deep learning, or would it be considered deep learning?
That is a great question, Apramey. Frankly speaking, on that end, there is no restriction whether would it be using a machine learning or deep learning. It all depends upon what route they want to take, Apramey. Again, going back to the previous discussion point where with Ananya, no one is stopping us to do hard coding of okay, when Ananya watches RRR movie, what should we suggest? If you want, you can explicitly write the logic if that is what your solution system going to be.
Right.
But that is not super favorable because you cannot scale it.
Right.
To overcome that problem, you are going to use an approach or a solution which uses machine learning algorithms.
Right.
Now, when you use machine learning algorithms, maybe you might do a good job for maybe 80% of the time. Okay. with by using, let's say, something called as NaiveBayes algorithm. Okay. Now, as a company, you'd always want to improve how well you are doing in recommending either the movies or the TV shows to the viewers.
Yeah.
Since deep learning algorithms would enable you to derive a lot more complex patterns, naturally, there is potential for you to do better with deep learning algorithms.
Gotcha.
So if Netflix decides to use deep learning algorithms to come up with recommended algorithms, recommendation systems, they can use deep learning as their solution system. Apramey.
Okay.
Okay.
Okay. So
So it can be in here too.
If you had to guess what Netflix currently uses with the amount of users they have and how accurate that recommender system is, would you say they're using machine learning or deep learning?
So I'm fairly confident they are using machine learning, as in it's machine learning algorithms, Apramey. Again, just to note, even deep learning is part of machine learning, right? So the right terminology to use is, this is deep learning, right? This particular box is deep learning, and everything else is called as shallow learning.
Okay.
Okay. So shallow learning and deep learning.
Right.
So Netflix is using shallow learning algorithms because of several benefits that you'd get. It's not always about improving the accuracy. There would be aspects of the complexities that would involve in sharing the amount of the data that you need to analyze. Okay. One of the main thing usually with the recommender systems is the data would be very, very sparse. For example, if Netflix has 1,000 movies, now, do you think you would have seen all 1,000 movies, Apramey?
No.
Not right. Very fraction number of movies and TV shows. Similarly, same thing with Ananya, Keval, Sandeep, everyone. Not every viewer would have seen each and every content that is available on them.
I'm an anomaly, Madhu, but yes.
Exactly. So Netflix should give you their subscription for free then, Sandeep. Yeah. So because of the sparse information, so whenever you do not have information on each and every content, in this case, let's say each and every movie viewed by each and every viewer, that construct of data is usually called as sparse data, because you can see data here and over there only, not in each and every. So if I have to fill up each column, if I have to split this entire matrix, entire box into 1,000 columns, one for each movie, and maybe 10 rows, one for each one of our team members. Now, if we try to fill in yes or no, if we try to fill in yes for all of the movies that each one of us have watched and nothing in the rest of the scenarios, then you'd clearly see that only few pixels would have filled up. Most of the other pixels would be empty. So that level of data, that type of data is called as sparse data. Okay. Because of some of the complexities that you would usually encounter with sparse data, which are not too favorable for deep learning algorithms. Okay. That's why they would be anchoring onto the shallow learning algorithms.
Okay.
But I'm sure they are using deep learning to come up with some of the other insights, as well as actually one of the other application. What image art to show for each of the movies, to, let's say, Ananya versus Keval versus Sandeep, because that can change depending upon who is looking at, okay, RRR movie, the image art, the thumbnail picture that you see, it could be different depending upon your own preferences. When I say preferences, your behavior.
Right.
Okay. So that is definitely based on deep learning.
Why would that be based on deep learning and not machine learning? Because wouldn't that also be sparse data too? Because I mean, how do the X and Y variables necessarily change for that?
So in this scenario, you are trying to identify what would be the best thumbnail for a specific viewer.
Right.
And the number of thumbnails for each of the movie would be very finite. It's not going to be in thousands. Right? And each of these thumbnail has very defined properties, like who is the actor, who is the actress, maybe is it more of an what is the genre of the movie, like action, comedy, very limited number. And for this limited number of attributes, or one thing is you have limited number of attributes, right? Now the question would be, depending upon what you have been watching against yourself, for all of the movies that you have watched, did you like comedy movies or action movies? Did you like few specific actors? Depending upon that information, you'd be able to so now with that context, if you use that context, the information is pretty dense because you're not trying to compare against other viewers. You would be taking in information from the other viewers, but not in a matrix format in this case.
Okay.
So that's how you'd solve this type of problem, Apramey.
Okay.
And since it's a dense data, you don't encounter significant issues with using the deep learning algorithm.
So just to one last clarification.
Yeah, please.
So when they're actually recommending a movie, is it comparing it with other users too? Like, is it not just, because I know we talked about for the poster, we're looking at you're comparing it within yourself, what you watched in the past, what actors you liked. When it's recommending a movie, does it not do the same? Does it compare it with, like, would it compare me and Ananya? Like, why would it need to do that to recommend a movie?
Yeah. For exactly the same reason that Apramey have not seen, so have seen only like very fraction of the movies or the content that's available on Netflix.
Okay.
Right. So it's going to take information from whatever you have seen as well from the past, but that is not sufficient enough to do a better job in coming up with relevant recommendations, Apramey. You're spot on. Again, if you want to design a solution like that, okay, just use what all information, what all viewing behaviors that I have had in the past. Just use only that to come up with the recommendation. Yes, you can definitely build a solution like that. And you can use deep learning or any other algorithms. Okay. But practically what happens is the performance, the amount of recommendation, the quality of the recommendation that you get wouldn't be of high quality.
So let me ask a question, Apramey and the rest. When I join as a new user on Netflix or Spotify or even Amazon, I haven't yet watched much yet, or I haven't bought much yet. What should Netflix or Amazon do? How should they recommend to me?
I think
probably.
Go ahead.
Yeah. Okay. I guess based on your demographic information, they would recommend the most popular movies, someone of your age and the region that you live in.
Okay. In a lot of cases, when I sign up for a service, they don't ask me for my demographic information. They may ask me for my email address and just let me sign up.
So actually, when we log in, when we register for Spotify, initially they asked what are your favorite people, like singers, or what is your favorite genre, or stuff like that. We just need to click them. That would actually help them a lot, I think. They just give randomly in that subgenre. so that when we start listening completely or just skipping things, then they might have some information about what we like. But else, they might initially need to give us some random stuff, and then based on that, they need to proceed.
Right.
It's just a
Yeah, good point. Keval, go ahead. Keval, then.
Also, over that, I think when Netflix asks you for a movie which you would like I just made a new profile and asked me for 3 movies I would like, and based on that, it was adding it to my list and recommending on that. And also on the demographic part, I think even if they don't ask it, they can easily know from your IP address that what larger part of the city or what place you are accessing the Netflix from. So based on that and the time you are watching, so if it's a lazy afternoon on a Sunday, probably a person would be watching some kind of a fun movie to relax or something like that. So those things also contribute in what things they recommend, and based on that, it would improve more.
So let me complicate the question now. So I live in my house with my wife and 2 kids, and each of us likes very different kind of movies. So same IP address, same zip code, same lazy Sunday afternoon, but each of us gets a different recommendation.
So in that case, if you are doing that, so basically with the IP address, the email you are signing in with would also have your birth date and the other informations. So those can be some of the things which can be also utilized. And for the kids, also Netflix has different profiles. So the recommendations won't be messed up based on that. And even if you would be living in the same house, probably if you are there are 3 people sharing Netflix, I don't think so everyone would be using the same profile. That's the reason they have the profile window to segregate things.
Yeah, and I feel like if you're at a point where you have 3 separate profiles and you're getting multiple variations, I don't think you're still in that stage where there's a cold start anymore, because by that point you probably all of you have put in different inputs for your different profiles, allowing it to give different recommendations.
Okay. Ananya and Bitan, you came off mute as well. Anything you want to add?
Yeah, I was about to mention about the cold start problem. So I remember when I had initially come across the cold start problem, I had looked at how Amazon at least initially used to solve it. So they had this thing where they would products at users and try and see if they clicked on those products. So what it would do is give a weighted average of which products were like clicked on by a particular user, and then it would try and figure out which particular other user that particular user was similar to, and then create a sort of similarity matrix, and then get started from there. So usually, even nowadays, I believe when you make a new Amazon account, your first one of the key things that you see, even if you're a single person with and are not married, is a diaper, because most of the biggest product that is bought from Amazon, one of the biggest ones is our diapers. So that's one of the things that I remember from like the cold start problem that Amazon and how Amazon solves it. But coming to Netflix, I believe there is they do have a couple of things. So a movie recommendation is something that I have worked on during my university time, and then during my bachelor's, one of the things that we had noticed was Netflix does not use deep learning specifically to generate recommendations, because it has 2 particular issues. One is that deep learning has this tendency to overfit, and Netflix does not want you, the user, to constantly see things that you like all the time, because it also wants to bring into fold the new things that Netflix is generating. So it wants you to grow as a movie buff, maybe, if we had to say it in that way. And another thing that they have a problem with is, as Madhu mentioned, there's a lot of sparse data. With even if you're a user who's been there for like 10 years, there's still a lot of sparse data. And dealing with that is easier using a particular method called SVD, or singular value decomposition. which is a better statistical machine learning model to use in case there's a lot of sparse data and making a matrix out of that. So that was more or less what I wanted to say. Sorry.
Thanks, Bitan. Ananya?
I pretty much had to say everything that Keval and Bitan said already.
Okay. So what we are hearing is that there are many, many strategies that one can use to develop a recommendation engine, but there are also as many constraints and challenges and factors to be considered. So the answer is that it is very context dependent on what are we trying to optimize on, and therefore what is the best solution to use. So as an example, a lot of you were talking about using my parameters, like my IP address, my age, my demographics, to recommend movies to me. But imagine if I hadn't watched a lot of movies on Netflix, but I had 15,000 other people who are like me, who actually have watched a lot of movies, then it becomes very easy for Netflix or Amazon or any of these systems to recommend something to me that people like me may like. So that is one strategy that you can use, not just for the cold start, you can use that strategy to do recommendations. And then you can combine those strategies with other strategies, all of you touched on some, and create some sort of an ensemble strategy to do the recommendations.
Yeah, that makes sense. Thank you.
Okay. Yeah, again, great discussion. It has been almost 50 minutes. We covered one slide. I love this engagement. Okay, thank you. So moving on to some of the examples on the deep learning. Again, the self-driving cars. If you want to detect any objects on the roads, pedestrian detection, traffic light detection, we discussed some of these applications. You can use deep learning algorithms to as a solution to build a system which identifies again humans or traffic lights.
Would you consider something like Alexa a deep learning solution, a Siri a deep learning solution?
I think they're based on RNN, so that is a deep learning solution.
Another example I remember would be like how Apple Photos app, uses RNN to categorize objects like cats, dogs, all of that. That's like very useful.
Yes. Yes, Ananya. Yeah. The moment when you use any version of the neural networks, network-based algorithms, and typically the notion is the moment when you have multiple layers, more than 3 layers, it's considered as deep learning. There is no strict guidelines that, it has to be, these are more number of layers. Generally, again, the simplest neural network would be something like a wood to wake or dog to wake algorithms, if you have heard about it in NLP, where you have an input layer and an output layer and then just one layer in between. That's it. That is one of the simplest network that you can create. And then in terms of the general terminology, anything deeper than that is called as deep learning.
Madhu, do you want to touch on explainability here, or are you going to cover that later on?
So we don't have it covered in as part of the AI overview, Sandeep. Okay. But good point. I think we should spend maybe a couple of minutes on that one, Sandeep. So in those angles, let me take a step back and ask a question. If when you step back, when you look from the artificial intelligence from this broader point of view, it feels like, you have all of the benefits the moment when you start using the deep learning, right? So which means you can try to build whatever problem that comes up. You can try to whatever machine learning or whatever decision-making problem that comes up with to your hand, you can probably solve it with deep learning. Right? That can be your de facto approach. Are there any counter arguments to this?
I think Bitan mentioned this in the first lecture. Like, you can make it complicated, but try to think about simple regression whenever you can.
Yes. Why?
Can I take issue to the term lecture?
Discussion.
So why Chiren? Why do you think he suggested linear regression?
So this is also something I feel that in general, when you try to, like, there's problems like overfitting that also comes when you try to base your solution a lot on the problem, that if something new comes along, you don't know what to do with that. That is also there. And so one of them is, of course, the simplicity. Second is learning. It's easier to with linear regression. There's a lot more scope. I would say the computational, it's pretty easier as well.
Yeah.
I think that's about it. I think Bitan could add more.
First, I want to summarize. One is to reduce overfitting, and the other thing is to reduce the computational time. Okay. If anyone else wants to add to this, please go ahead.
I think there's a lot of focus on getting accurate results, and I think we've forgotten the basic of computer science, where it talks about Occam's razor and things like that, where Occam's razor is basically, if you have a solution, you should try and strip down all the things that feel like excess, so as to get it to the most efficient solution as possible. Like, it basically talks about how the simplest solution is usually the most efficient solution. And I mean, that makes sense, because what Chiren said as well, like, overfitting is an issue that usually happens when we overcomplicate our models. It's great to try and figure out something like to the T, but if we keep training a model, we tend to overfit it to a point where it will cause a lot of problems later on. When we haven't seen certain types of data, it will not be able to figure out what to do with that kind of data. And there's also the fact that there's also the trade-off between efficiency and time with respect to accuracy. So I think I don't know where I read this, but there is this like really nice line somewhere where they said that as long as the model is accurate enough to give you decent results, you should go ahead and then use some kind of domain knowledge or somebody with enough domain knowledge to figure the results out, instead of having your machine get the outputs absolutely correct, because that is way worse than having something that performs decently and has somebody sitting at the background and then just sorting things out manually. That's more or less where I'm at by understanding.
Thanks, Bitan. Any other counter arguments to, let's use our deep learning always?
There's also go ahead.
Oh, sorry. Yeah. I think this was about explainable AI. Right? Most of the deep learning models are black boxes. As you add more layers, it's a more obscure and harder it is to understand what's going on behind the scenes. So explainability, especially to stakeholders, is important when you build deep learning models. And if you keep it simple and stupid, then it's easier for you to convince that this is what it's doing, rather than explaining, complex differentiation and integration that's going on behind the scenes. Explainability is important when you consider how complex your model should be.
Yes, Aditya.
Let's probe on that a little bit, Aditya. Can you give us an example where explainability is desired versus mandatory? Which means that I wish I could explain this versus I must explain this.
Okay. So
I can think of something where it's desired, maybe not mandatory, but something where it's desired is sorry, Aditya, I'm cutting in.
No, go ahead. You can take this.
So a particular place that is desired, and I think there's a lot of research that's going on with respect to explainable AI is LLMs. We have this tendency to think that ChatGPT is a know-all and be-all, but we've also come to the conclusion that even OpenAI, the engineers at OpenAI who are working on these models are not really sure how these models work. It works, and that's great, but they're not really sure how the connections have been made or how these things are actually, like, how it's coming up with answers to certain things and how it's actually failing to come up with answers to like pretty simple things as well. Like something that where it actually fails is logic. I think we had this discussion when we met in person. Like logic and math is something that ChatGPT absolutely like rubbishes. It's horrible at it. So math is something that's pretty like scientifically proven, and it's step by step. So something that is that simple to explain even to a kid, where ChatGPT fails absolutely, is a place where I feel that we need to have some kind of explainability to try and figure out where it's going wrong in creating those connections. But the mandatory bit, I'm not really sure what to say with respect to that, to be honest.
I have examples for mandatory, which is if you have self-driving cars and it, for example, causes an accident, you can't say, I don't know why it did that. So that kind of black box approach is not appropriate there.
Something I wanted to say to Beaton too is I guess that it is desired for ChatGPT, but wouldn't you also say that like there is pushback and people want to know how it's going? So are we not going to a point where there's like people writing open letters saying like we need to stop this advancement in AI? So I guess you could even argue that even in regards to ChatGPT, there's definitely pushback from the consumers as well as people in the tech world that they want to see it in a mandatory way on why an AI model is coming up with the outputs that it is.
That's a great point, Ramey, but just keep in mind that there are a lot of things that are societal versus mandated by laws or regulations. And the difference, right?
Yeah, definitely.
So in the example that you shared, society might at large might want it, and at some point it may become law, but now it isn't.
Right.
It's not mandated. But there are several use cases where it is actually mandatory. So Chiren used an example of a self-driving car and the decisions it is making. Because there are humans at risk, humans and material property at risk. So one should be able to explain why the car is doing what it's doing. And there are several such examples. So for example, one of the areas that Madhu and I have worked on extensively is the credit industry. So if someone applies for credit and we use deep learning models to make a decision on whether we will extend them credit or not, but we were not able to explain why we came up with the decision that we did, especially if it is an adverse decision. We declined them credit. Then we have to explain why we declined them credit by law. Similarly, healthcare has a lot of such examples where if you're using deep learning for diagnosis, you have to explain why you came up with the diagnosis that you did. So I would encourage you to think about all of these factors when you're making a decision on which type of modeling technique to use, because there are a lot of considerations and a lot of factors. Go ahead, Abhilal.
No, I was not saying anything.
I just wanted to build off of that too. I feel like societally and within the government itself, there's like the huge tendency to on the issue of whether AI has like innate biases and then how that bias could potentially, harm minorities and people that are already disenfranchised. So I think that's definitely something to consider too when looking at a deep learning model. If it could potentially harm a minority or it could potentially harm someone that is already disenfranchised, that could lead to a lot of regulation from within the government. And I think that goes to the part of like the credit cards that you guys were mentioning too. Like if a credit card declines a person, for example, let's say of like African American descent, like that just starts a process like similar to like redlining where they're kind of harmed again. So that could lead to the government kind of needing to step in those issues.
So I'll actually give you a real example. Back in 2008, the big financial crisis, a lot of companies started tightening their credit, just like what's happening right now. And at the time, they decided to tighten their credit based on zip codes. And they actually hard-coded that for these zip codes, we will have a much higher threshold of other factors like income and so on. Or we'll just completely not give credit to these kinds of zip codes. So that would be an example. And a lot of companies ended up either getting sued or they were investigated by the government for unfair practices, credit practices.
Yeah, coming to like talking about explainability, even AI has a lot of applications in medical field. So the company which I was working last was actually filling medical prescriptions from speech. So they use a lot of NLP in between. So they were always very rigid about the explainability of what is being written into the medical prescription, because a simple difference of a gram and milligram of what the patient is being injected could kill the person itself. So that's where we cannot actually like just go on blindly trust ChatGPT to fill stuff like this, because that could actually cause dire situations. So it's actually, as Sandeep said, it depends on the context of where it is being used. If it is being used in a place where a little bit of error is okay, then it's really good. Like someone using it as a tool to edit their resumes or just writing some stuff, but it cannot be used in places where error should not happen.
Great point, Abhilash. Thank you. Back to you, Madhu. We can move from the first slide.
Yes, but great conversation, Sandeep, and everyone. Thank you. Yep. So I guess we did hear at least 4 different points. One is to reduce overfitting, and then
there was accountability
what is the
for
second?
explainability. Another thing I think I said was one of them was overfitting, another was simplicity. Like training. Yeah, simplicity for training.
Yes.
Yeah,
yes.
And ML ethics, basically.
Yeah. So ethics is a bit broader terminology, Bitan. Right? I think it goes back to, again, more from the artificial intelligence point of view, the different subfields that are in there. Explainability also falls as part of ethics, depending upon the application that you are using it, like healthcare, finance, different industries where you're using these solutions as solutions. Right. So reducing the computation time, model explainability, and which is, there was one more thing, the discrimination, I guess, probably Apramey, that you used as an example, which also falls under the ethics, Bitan, that you just shared. So keeping the decision-making systems fair and remove discrimination from the picture. So that is definitely another aspect. Yeah. So you have to balance all of these things when you are proposing or when you want to design a solution for a problem at hand, right? Depending upon, again, what is your application? And as Abhilash mentioned, are we okay with the error rate? Are we not? Accordingly, you would end up choosing, which particular box you should use as your decision-making system. Artificial intelligence, since you are explicitly writing the logic, a human is writing the logic, which means the human would understand what that logic is. So which means you would be able to explain it to the regulators, any type of regulators. So that is one of the places where it becomes a lot more simple. And for all of those critical systems, you can definitely keep using, again, explicitly written logic, where the error is absolutely not acceptable. Or you can use some sort of hybrid approaches, like maybe I might want to do some basic pre-processing with some of the advanced algorithms, deep learning algorithms, and then generate the information and then write explicit logic to make the final decision. So I can, as a data scientist, I can architect this entire solution considering all of these various points. So you need to keep all of these points in mind, depending upon which application you are implementing the solution for. Does it make sense? Any discussion point?
So the only comment I wanted to make, Madhu, is this is what you will learn to do as a part of the solution architecture step, the root cause and solution architecture step, which is the step 2 in our process. So after the story, we'll do root cause analysis and solution architecture. So we'll discuss for the design challenge that each of you is going to solve, what considerations should we keep in mind while making an architecture decision.
Okay. So moving on. Okay. So let's focus on the learning itself, where the decision is being taken by the system. The decisions are not being hard-coded by a developer. So which means both machine learning and deep learning. So within the entire field of machine learning itself, are you aware of the different types of learning methodologies that exist? You're on mute, Bitan, if you're speaking.
Sorry, I was saying supervised and unsupervised learning is one.
Okay.
And then
Nice.
what else do we have?
There's reinforcement, supervised and supervised and
Semi-supervised, basically.
Who said semi-supervised? Abhilash?
Abhilash, yeah.
Thank you.
Reinforcement learning is semi-supervised. As much as I read, obviously there are people who argue otherwise, but yeah.
Yes. I would probably fall under one of those people, I guess. Yes. So if you want, I think you covered supervised learning, unsupervised learning, reinforcement learning. And we can definitely add one more box explicitly for semi-supervised learning as well, Abhilash. Okay. So let's come back to the semi-supervised after a few minutes. First, let's cover, just to make sure that everyone is comfortable with each one of these.
Yes, of course.
All right. So let's focus on supervised learning first. Any other categories that you can think of in supervised learning?
I guess based on the kind of machine learning task that you're trying to do, whether it's a regression problem or a classification problem.
Perfect. And
That
can you
would be
take
two broad categories.
Yeah. Yes, sir. Can you take maybe an example in each?
Yeah. So regression is if we're trying to, let's say, forecast the rain for next week or something like that, a number.
Perfect.
And classification is we're trying to categorize between whether it's binary or multi-class, whether it's a cat or a dog in a picture, anything, wherever we're trying to differentiate between one kind of data point and the another data point, that will be classification.
Spot on. Yeah. You just hear a few other examples, but you're spot on. Yeah. Any questions on the classification or regression? Okay, so let's move on to the unsupervised learning. Are there any categories within this?
There would be clustering.
Okay. Are you speaking, Bitan? All right. Yeah. So yes, clustering. That is the type of problem that we'll be solving. Dimensionality reduction, truly speaking, it's not a category. It's more of a technique. So you use unsupervised learning to reduce the amount of data that you have in hand and make it more meaningful. Okay. I think, yeah, that's probably the perfect sentence. To make the data a lot more meaningful and remove any of the repeated information. For example, okay, so I use 4 words now. Effectively, I can try to reduce it to maybe just I think, or I mean, or maybe something else I want. It just compressed 4 words into 2 words, essentially keeping all of the unique information. I wouldn't say unique, all of the essential information in. That's exactly what you try to do in dimensional reduction. Is that itself taking a decision for you? The answer is no. Because on top of that, you need to process that, you need to use that information to build another decision-making system to come to the final decision. So the dimensionality reduction branch itself would not take a decision for you. It would synthesize the data for you to be a lot more meaningful. That can be fed into a decision-making system like any other machine learning algorithm or deep learning algorithm and have the decision taken at that end. Okay. So when you look at any of the classification algorithms, at the end of it, you would have a decision, yes or no, cat or dog, right? Similarly, with respect to the regression, at the end of implementing the regression algorithm, what you'll have is how much rain did you see? Or how much rain are you going to see next Monday, maybe something like that, if it's going to rain. Similarly, with respect to the clustering, what you'll say is, okay, this is a group of maybe animals which has maybe horns. These are the group of animals who fly, which fly. I don't know. Yeah.
Okay. I had a question.
Yes.
So, as in the flowchart, the dimensionality reduction has image recognition and the supervised learning has image classification. So, how would that relate? Would it be that the image recognition would be mainly used in a way that if a blur image is given, it would try to make it sharper and recognize it, and while the classification would classify what that image is? Because that's what I was confused.
Sorry, give me just a second. Yeah. So these are more of applications, Keval. I just want to call that out. As in, you can use dimensionality reduction techniques for text mining. Just the example that I just shared with you. I had 4 words. Now you can use something like principal component analysis algorithm to reduce it to 2 words. Okay. You're trying to mine meaningful information from plethora of information that you have in hand. Same thing with the applications like face recognition or image recognition in general. What you're trying to do is usually the images would be quite huge, as in the data in each image is huge. If you have an RGB image, 3 dimensions RGB each of the for each of the channels, and if it's a HD picture, now you have 720 divided by 1024 pixels. So that comes down to almost almost 2 million points. Each image, each RGB image is 2 million points. Just imagine. If you want to process that level of information, again, going back to the point, to keep it simple and stupid. I don't know who made this statement. I love it. Simple and stupid, I guess. Instead of processing 2 million points, now you can effectively reduce it to maybe say 200 points, so that your computational time would be a lot more faster if you want to make a decision. Okay, so it's in those lines on how it is represented as an application of dimensionality reduction. Did that help, Kevin?
Yeah, that makes sense.
Any categories or any applications that you can think of for reinforcement learning?
Because the Mario game that we did in the last one would be an example.
Yes. Yes, sir. Okay. So, okay, here you can see a few more examples. One thing that maybe you can guess, I guess, or can you give an example of how inventory management can leverage a solution like reinforcement learning?
Like by inventory management, you just mean like companies and the inventory that they have?
Yeah, yes.
I guess it could use reinforcement learning to see like based on how much inventory it currently has and the customer demand for something, it can keep like telling the model like right now, like you can like positively affirm it like when it's keeping the correct amount of inventory, but like let's say there's too much inventory and stuff are expiring, or there isn't enough inventory and customer demands aren't being met, then it can negatively have the enforcement so that the model knows like we should change it and have an accurate amount for next time.
Yep.
I think inventory management comes into the larger section of supply chain optimization. So if you have a whole supply chain, at which point should you move what items also depends. There's logistics that's come into play, and that could be optimized with reinforcement learning.
Yes. 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 So think of any specific thing where, you know, some event or some action can impact the company's business. Okay. If it's impacting it in a positive way, try to reward it. If it's the other way around, try to reward it or try to penalize it. Right. Going back to an example like the expiry date Apramey that you just mentioned. So that definitely a parameter which can help the companies to prioritize some of the products which are going to expire and push them ahead in the pipeline in the supply chain management, right? Sure. and you can try to push it in front of the customers so that they're out of their stores or their companies as soon as possible. And from a different point of view, let's say if your inventory management is in a way that you keep incurring losses because of the expired products. Now, in those scenarios, you are giving the algorithm thumbs down. So you're penalizing it. So try to figure out if there are any other optimization methods that you can leverage to reduce the wastage, the expired products. Does that make sense?
Yeah.
I'm not sure if I cut someone else off. Was someone trying to speak earlier?
I had a question. So one of the problems I was interested in, so one of the professors at ASU was working on this. I think they were working with FedEx to optimize the way they put cargo in a plane. So would that also be a part of like inventory management and reinforcement learning where they use lidars to map the plane first, and based on that it would tell how the inventory would be placed in a cargo to utilize the maximum space, and if it is not able to do it properly it would be penalized, and if it is doing it correctly it would be rewarded?
So, okay, actually, I don't want to answer first. Let's see what the rest of the team think about that.
I believe not, because so inventory management, yes, but RNN, no, because each case would be different. So the reason I say that is because there's no learning to be had in that particular scenario. It's more on mapping, which is a very like nominal task in itself. If I'm mapping space or geospatial, like I won't say geospatial, but then spatial data is pretty simple to map in terms of like where we are right now in terms of our like life cycle of machine learning and deep learning. So the reason I would argue that it's not is would be that there's no real learning that it's happening where I can reward the system and ask it to keep like iterating forward into other use cases other than the one that I'm particularly in and in this particular batch, so to speak. So each batch would be a different iteration altogether. And in that way, I think it would be more disjoint than saying that if I have an RNN model, it usually is not that just disjoint. Each batch would be related in some way or the other. But in this particular case, I don't believe there would be any relation. That is my understanding.
Any other opinion?
I would agree with him on that one.
Ananya, you came off mute several times, but you haven't spoken. So anything you want to share or ask?
Yeah, I was just like summarizing what reinforcement like would be in a much like simpler way. Like for me, I remember learning that the data, the model is trained on based on the decisions that based on like interacting with the environment and receiving feedback on like receiving feedback in the form of penalties or rewards. So, yeah.
One of the ways I think about reinforcement learning is how we train our pets. So if I'm training a dog, because cats are, I think, impossible to train, is if the dog does what we intended to do, we will give it a treat. And if it doesn't do what we intended to do, then it'll not get a treat. So that is one simple example that I keep in mind when I think of reinforcement learning. And if I apply that to any certain situation, that I'm trying to teach the system a certain pattern of behavior by either saying what you're doing is right and keep going in that direction, or what you're doing is not quite right and I'm going to penalize you. So don't go in that direction. So I'm guiding that system to go into a certain direction, but I'm not telling it which direction to go to. The direction it goes to, it's discovering on its own. I'm just validating or not on whether the direction is right. That's how I think of reinforcement learning.
That's a great analogy, Sandeep. Thank you for sharing that.
Quick time check. So we are on the top of the hour, Madhu.
Yes.
So let's wrap up.
Yeah. Yes. So on loading the cargo itself, maybe before I answer that, let me ask a question. So who is, maybe take one, I guess. You have all of your inventory and you're trying to load the cargo. What would be your strategy of loading the cargo? As in, if you have 100 items, how do you decide which item should go first? And each item, I'm assuming that each item size is different. Keval? Okay. So who is making the decisions of which item should go and in which location?
I think what they were trying to do is they were trying to first do a random way of fitting it, and then based on that they were trying to optimize it.
Okay. So if there is iteration number 1, completely random, and you notice that there is X percentage amount of void space now, okay, what would you do next in iteration 2?
For the iteration 2, I would try to make a specific approach which would try to fit in. So instead of randomly, I would try to fit the larger boxes in a specific way and then the smaller boxes on the limited spaces, and then see if that works. So something like that.
Got it. So if a human is doing all of those, is making all of those decisions, Kevin, so as Bitan mentioned, there is no learning by a system, a computer system, by a machine, right? So in those scenarios, it's more of the entire field of study is called space optimization for inventories. It's a very well-known problem. And all that you are trying to do is, actually it's called a packing problem. How you try to pack things into a given space. Okay, like set of balls into a cubicle or rectangular box, just as an example. Yeah, so if the decision is being taken by a human, then it would be more of that packing problem. If there is some other system which is taking those decisions, for example, somehow if there are sensors within the cargo itself, which is automatically identifying where the void spaces are, and then trying to take decisions accordingly between iteration 1, 2, 3, and so on. So in that case, it would become more like reinforcement learning.
So what I was saying is that they don't actually pack it, but they just use a LiDAR scanner to map the things in the space. And based on that, through that data, it would say that if there are blank spaces over here, so that data would be continuously going through a computer, which would decide on what to do. So what would that lay on?
Good. Even over there, again, the decision of what should be my approach for iteration 2 and 3, who is making that decision? So that gives you the answer, Keval. Is it going to be reinforcement learning or is it just a packing problem?
So, Keval, one way to think about that is if the LiDAR did the scanning, the system loaded the boxes, and then there was some kind of feedback using some sensors. And the next time it had to do it, it actually improved or optimized, then that would be an example of reinforcement if it continues to improve based on the feedback. But if there is no automatic feedback and the system isn't learning and doing better in the next iteration, then it's just a packing problem.
Okay, got it.
Okay. with that, I think we wrapped up this particular slide. We do have a few more topics that we need to cover, which we'll be doing it in the subsequent sessions, everyone. All right.
So we are not doing Teach to Learn next session then?
Not tomorrow.
I wanted to ask a quick question. If any of you wants to meet in person anytime this month, then do please let us know. If there are a lot of you who want to meet in person, then we can schedule one of the upcoming sessions like that. Any other logistical items, Madhu, before we wrap up?
Nothing, just that Sandeep has shared the session recap for session number 2, and we'll be doing that in the next, before tomorrow morning or afternoon for this session. And please review it if you want to check out, either the additional material or even some of the discussion points that we had. Okay.
Thank you, everyone, for your engagement. Have a good rest of your weekend. We'll see you tomorrow.
All right.
Thank you.
Bye.
Bye-bye.
Bye.